All right, let's see if we can do another one of these derivative pieces that, like we did in class today, showing one of the order of the approximation forms. So let's prove here that f prime of x is equal to 4f of x plus h minus 3f of x minus f of x minus 2h all over 6h and plus O of h squared. Let's see if we can verify this formula. All right, again, all of these are going to be based on our power series expansion for f of x plus h. So that's f of x plus f prime of x h plus 1/2 f double prime of x h squared, 1/6 f triple prime of x h cubed, and so on. Again, we're trying to find a formula for f prime. So if I'm trying to find a formula for the f prime, that means I'm solving probably for a piece here. Notice the f prime has the h on it, so I'm going to divide the h out when I solve for f prime of x, and notice I also see that up here in the numerator, or excuse me, the denominator of the fraction of the formula we're given. If I'm going to divide through by h, and I want O of h squared for my error on the end, that means I need to have my error before I divide in terms of h cubed and higher, meaning this term, the h squared term, needs to go away. So that's the part that we're going to concentrate on. All right, looking at our numerator, we've got an f of x plus h and a minus f of x minus 2h. So let's compute f of x minus 2h. That gives us f of x, because there's no h there, minus 2f prime of x h. The next term will still be a plus because I'm squaring the negative. I'll get a 4 times a half. So that's going to be 2f double prime of x h squared. We'll get a minus, and again, we'll have an 8/6 to be a 4/3 f triple prime of x h cubed, and so on down the line. Again, my goal here hopefully is to eliminate the h squared terms. To do that in this case, I could multiply the first one by 4 and subtract, and that'll get rid of the h squared terms in the result. So we take 4 times f of x plus h minus f of x minus 2h. That gives me 4f of x minus f of x is 3f of x. Get 4f prime of x minus 2f prime of x gives me plus 2. Oops, I'm sorry, I'm subtracting. I get 4 f prime of x h minus a minus 2, so I get plus 6 f prime of x h. The middle terms cancel, not the middle terms, the h squared terms cancel. We're trying to show this is O of h squared. We've already talked about how we want the h cubed, so that when we divide by the h, we get h squared. I don't care what the constant is, so I'm just going to write a plus a k h cubed here. And then so on down the line, higher powers of h. Don't care what the h is because I want that in my error term anyway. All right, so now solve for your f prime of x. Notice I will need to subtract the 3x over, divide by the 6h, and then that'll leave me with kh squared. So you get f prime of x equals 4f of x plus h minus 3f of x minus f of x minus 2h all over 6h plus O of h squared in this case. So this would be what you would want to do if you're trying to prove one of these approximation formulas along with the error term.